The James Webb Space Telescope is identifying objects in the dark ages that, by the best measurements we have, are large, fully developed galaxies. This raises the question of whether the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe we've all seen in some movies and television. This brings up the question of whether computer games are becoming so realistic that the avatars within them could actually be real. To elaborate, consider the scenario in which we are the dreamers, and the individual who presses the play button to begin a video game is having a dream. The existence of reality itself is therefore determined by cosmic consciousness. This leads to the thought, computer games are becoming so realistic that maybe these avatars are real, and maybe we, too, are avatars, nothing but cosmic, digitized figures dancing on somebody's computer screen. What is out there in the cosmos? This question has confounded many people before us and will likely continue to perplex many after us. The size of the cosmos is so vast that even with the unobservable portion excluded, astronomers have not been able to estimate its full circumference. Let's say that this person who hits the play button starting the video game has a dream and we are the dream. The limitations of materialism, the notion that humans are nothing more than atoms, are among the many things that ancient philosophers got right. The observable universe, however, is the portion of the cosmos that we can see and study with telescopes and other tools. It is restricted by the finite speed of light, which means we can only directly witness things that are not too far away or too long ago from us. The estimated diameter of the observable universe is approximately 93 billion light-years, which is significantly larger than the estimated age of the universe, which is 13.8 billion years. The universe's expansion has forced objects to move farther apart, creating a disparity in the time it takes for light from those objects to reach us. To explore the cosmos beyond what is currently known, space-time travel mechanisms like wormholes and warp drives are necessary. These ideas are hotly debated and currently unattainable with human technology. According to the cosmic inflation theory, the cosmos is at least 10 to the power of 23 times larger than the observable universe. We are unable to comprehend the vastness of the scale, but we can develop theories based on information from distant galaxies and other sources, with NASA playing a major part in this investigation. Our knowledge of the cosmos has greatly benefited from the work of NASA and other space agencies. NASA shared images taken with the Hubble telescope of the extremely deep field prior to the James Webb Space Telescope, JWST, coming into operation. The furthest galaxies ever observed were captured by the JWST at launch, depicting them as they might have appeared a few million years after the Big Bang. The JWST can reveal galaxies that were formed early in the history of the universe since it can detect infrared radiation. Thanks to these observations, a sizable population of early star-forming galaxies has been revealed, some of which date back to up to 300 million years after the Big Bang and were previously unknown. For a very long time, people have been curious about our place in the cosmos. The findings of the JWST imply that millions of galaxies may support life in the unobservable region of the universe. The likelihood that there is life elsewhere in the universe is growing stronger. The transit and radial velocity approaches have revealed a large number of exoplanets that may resemble Earth and perhaps harbor life. The presence of water molecules, haze, and clouds on the exoplanet WASP 96b, as revealed by the JWST, suggests that the planet may have habitable conditions. The many-worlds interpretation of the term multiverse refers to the existence of numerous other universes or realms beyond our own. A quantum system may collapse into a single state in quantum physics upon observation, but in the many-worlds interpretation, the system breaks into several states, each representing a distinct conclusion. The concept of a multiverse broadens our understanding of the possibilities in the cosmos, even though it is still very theoretical and lacks solid proof. With the help of telescopes like the JWST, we are able to gain further insights into the structure, composition, and history of the vast and intriguing observable universe. We are reminded that there is much more to learn by the notion of extraterrestrial life and the possibility of a multiverse. Verifying the existence of a multiverse is a challenging task, and while some philosophers and scientists find the idea intriguing and possibly helpful in understanding some facts, others remain unconvinced. The idea that there could be more than one universe is as plausible as Schrödinger's cat, since we have no idea what exists outside of the cosmos. Is there a dark flow? The dark flow is a phenomenon that was first postulated in 2008 as an explanation for why, given the known distribution of matter in the universe, some galaxy clusters appear to be moving faster than expected. According to the theory, these galaxy clusters might be pulled in a specific direction by dark or invisible matter or energy. However, there is disagreement within the scientific community over the presence of dark flow. While some investigations have been unable to prove its presence and have instead attributed the apparent motion to systematic measurement mistakes, others have suggested that it might be real and could be created by a huge, enormous structure in the cosmos. Dark flow could potentially exist outside of the visible cosmos. Is there really a black hole? A black hole is an area of space where light cannot escape due to the intense gravitational pull of the black hole. Black holes, which can have masses ranging from a few times that of the Sun to millions or billions of times that of the Sun, are created when a star collapses at the end of its life. It is challenging to estimate the likelihood that black holes exist in the unobservable universe. Although the quantity and properties of black holes in the unobservable cosmos cannot be determined with certainty, it is highly probable that there are many of them throughout the universe. Is dark matter real? It is believed that dark matter, a hypothetical type of matter, accounts for about 85% of all matter in the universe. It is difficult to directly detect because it does not interact with light in the same way as ordinary matter, hence the name dark. Its gravitational pull on observable matter and the way it bends light from far-off objects suggest its presence. The scientific community acknowledges the existence of dark matter, though little is known about it, and its nature remains unknown. Scientists have various theories regarding its potential qualities, but none of them have been proven. Another enigma that might be resolved by peering outside the confines of the observable universe is dark matter, which could consist of particles that have not yet been detected. NASA and exploration future. The James Webb Space Telescope, JWST, was built to capture photos and spectra of solar system objects, as well as observe the universe's furthest reaching objects. It is anticipated to investigate exoplanet atmospheres and offer new perspectives on the genesis and development of galaxies and stars. The JWST is still in the process of being launched and commissioned, but it is expected to significantly advance our knowledge of the cosmos. It might discover novel and unexpected phenomena that could contradict what we currently know about the universe, possibly leading to the discovery of extraterrestrial life earlier than predicted. Meanwhile, in order to gain a deeper understanding of the physics governing the observable universe, and to discover more about its composition, structure, and history, scientists and researchers continue to study it. Until then, there remains both curiosity and anxiety associated with the unknown that lies outside of our observable cosmos. The question of whether we are alone in the universe has fascinated humankind for centuries. From ancient philosophers to modern scientists, the search for extraterrestrial life has remained a pivotal aspect of scientific inquiry. The discovery of exoplanets, planets outside our solar system, has significantly altered the landscape of this search. The sheer number of these exoplanets that may possess Earth-like qualities suggests that the potential for life beyond our planet is not only possible but increasingly plausible. As telescopes like the James Webb Space Telescope, JWST, peer deeper into the universe, the chances of finding planets with conditions conducive to life rise exponentially. One of the most important factors in determining whether a planet might support life is its location within the habitable zone of its host star. This zone, sometimes called the Goldilocks zone, is the region around a star where the temperature is just right, neither too hot nor too cold, for liquid water to exist on the planet's surface. Liquid water is considered a key ingredient for life as we know it, and its presence on an exoplanet increases the likelihood that life could exist there. Researchers have used this criterion to identify potential candidates for further study. Some of the most promising exoplanets discovered so far lie within the habitable zone of their stars, and the JWST is poised to provide invaluable data about these distant worlds. The discovery of water vapor in the atmospheres of exoplanets is another breakthrough. One of the most notable examples is the detection of water vapor on the exoplanet K2-18b, a potential candidate for supporting life. The presence of water vapor, combined with other atmospheric characteristics, has fueled speculation about the potential for life on planets far from our solar system. Scientists are now focusing on analyzing the atmospheres of these distant planets to detect biosignatures, molecules or gases that could indicate biological activity. In addition to water vapor, scientists also look for other potential signs of life, such as methane or oxygen, which, when found together, might indicate biological processes. The possibility of life beyond Earth also ties into the broader concept of panspermia, which suggests that life may not have originated on Earth at all but rather been transported here from elsewhere in the universe. While this idea has not been proven, it has garnered interest as new discoveries in astrobiology continue to suggest that the building blocks of life may be more widespread than previously thought. Some researchers believe that meteorites or comets, which have impacted Earth over the millennia, could have carried microscopic life forms or organic molecules that seeded the planet with the ingredients for life. This theory, although speculative, opens up the fascinating possibility that life is not unique to Earth but is instead a widespread phenomenon across the universe. In parallel with the search for life, the study of the universe's origins and its ultimate fate continues to captivate scientists. The Big Bang Theory, which posits that the universe began as a singularity, a point of infinite density and temperature around 13.8 billion years ago, is the leading explanation for the universe's origin. Following the Big Bang, the universe expanded rapidly in an event known as cosmic inflation, cooling as it grew and allowing for the formation of the first stars and galaxies. This process, which is still ongoing, is responsible for the current structure of the universe, with galaxies, stars, and planets scattered throughout space. The JWST, with its advanced infrared capabilities, is providing us with a closer look at the earliest stages of the universe. By observing light from galaxies formed just a few 100 million years after the Big Bang, scientists can begin to unravel the mysteries of cosmic evolution. These observations could help answer some fundamental questions. How did the first stars and galaxies form? How did the universe evolve into the complex structure we see today? And perhaps most intriguingly, how did the fundamental laws of physics as we understand them come to be? By observing the oldest and most distant galaxies, the JWST is pushing the boundaries of our understanding of cosmic history. While the JWST focuses on deep space observations, other telescopes and missions are focusing on our own solar system. One of the most exciting frontiers in space exploration is the study of the outer planets and their moons. The discovery of subsurface oceans on moons like Europa, Jupiter's moon, and Enceladus, Saturn's moon, has sparked speculation about the possibility of microbial life existing in these hidden oceans. These moons are thought to have liquid water beneath their icy crusts, and the presence of such environments has led scientists to consider them as some of the most promising places to search for life within our own solar system. Upcoming missions to Europa, such as NASA's Europa Clipper mission, are designed to explore these moons in greater detail, sending probes that will analyze their surface and search for signs of biological activity. In addition to these exciting prospects, space exploration has also raised questions about humanity's long-term future. The idea of humans becoming an interplanetary species, capable of living on planets beyond Earth, has been a topic of speculation for centuries. However, recent advances in space technology have brought this vision closer to reality. Companies like SpaceX, founded by Elon Musk, have set ambitious goals for the colonization of Mars. Musk's vision of establishing a human settlement on Mars is based on the idea that humanity must become a multiplanetary species to ensure its survival in the face of potential threats, such as climate change, asteroid impacts, or other catastrophic events. The concept of interplanetary colonization raises both technical and ethical challenges. One of the most pressing issues is how to sustain human life on another planet. Mars, for example, has a thin atmosphere and extreme temperature fluctuations, making it inhospitable for humans without the aid of advanced technology. Space habitats, life support systems, and sustainable food and water sources would need to be developed to support human life on Mars. Additionally, ethical concerns about the impact of human colonization on other planets and their ecosystems must be carefully considered. While the idea of space exploration and colonization is thrilling, it also raises questions about our responsibilities as stewards of other worlds. As we look beyond our solar system, The possibility of traveling to other stars has long been a topic of interest for scientists and science fiction writers alike. While the distances between stars are vast, researchers are exploring potential methods for interstellar travel. Concepts like the warp drive, which would involve manipulating spacetime itself to achieve faster-than-light travel, are still purely theoretical, but they offer a tantalizing glimpse into the future. Another possibility is the use of generation ships, massive spacecraft designed to carry multiple generations of people on long journeys to distant stars. These ships would function as self-contained ecosystems, with people living and dying on board as the spacecraft travels through space. While these ideas remain speculative, they provide insight into the future of human space exploration and the potential for interstellar colonization. In the meantime, advancements in artificial intelligence, AI, and robotics are playing a crucial role in space exploration. AI-powered systems are already being used to analyze vast amounts of data collected by telescopes and space probes, allowing scientists to make new discoveries more efficiently. In addition, robotic missions have become essential in exploring distant planets and moons. Rovers like Perseverance, currently exploring Mars, are equipped with sophisticated AI systems that enable them to navigate the Martian surface, analyze samples, and conduct experiments autonomously. These robotic explorers are laying the groundwork for future human missions by providing valuable data about the environments we may one day visit. Looking further into the future, space exploration may not only answer questions about the origins of the universe, the potential for life elsewhere, and the fate of our planet, but it may also help us understand fundamental questions about our place in the cosmos. The study of dark matter, dark energy, and the fundamental forces of nature will likely lead to groundbreaking discoveries that could revolutionize our understanding of physics and the very nature of reality itself. As we push the boundaries of what is known, the pursuit of knowledge will continue to inspire new generations of scientists, engineers, and explorers. Ultimately, our quest to explore the universe is not just about understanding the cosmos. It is also about understanding ourselves. The universe is vast and mysterious, and the more we learn about it, the more we realize how little we truly know. But in this pursuit of knowledge, we are driven by an innate curiosity, a desire to explore, and a longing to answer the big questions that have puzzled humanity for millennia. As technology advances and our understanding deepens, the future of space exploration is bound to reveal discoveries that will forever alter our perception of the universe and our place within it.